In this video, we'll talk about how we can count something using complements. So I want to motivate this with an example, which says that a website requires passwords whose characters can be letters A, B, C, up to Z. And these are not case sensitive, which means that we don't care about whether it's a lowercase or a capital letter. For our purposes, that's the same. Or the characters can be digits, the digits between 0 to 9, all of those integers. How many 10-character passwords have at least one Z in them? So let's talk about the solution to this question. So first I want to think about what would happen if we tried to count this directly. This requires cases because we could have a situation where there's just one Z in the password, and maybe the Z is in the first spot, and then we have all of the other letters after that. Let me just put a blank spot for each of those other letters. Or maybe the Z is in the second spot, so I have some blank letter, Z, some other letter, and then until I get to the end. And I could keep going like this until maybe the Z is in the very last spot. And then we have all the letters before that. Okay, that's only if I have one Z. What if I have two Z's? If I have two Z's, I could have something like Z, Z at the front, and then all of the other letters. Or maybe it's a Z first, and then a different letter, and then the other Z, and then all of the other letters. And I could keep going like this and think about how to put those two Z's in different spots, and then I have to do 3 Z's and 4 Z's and so on. And this is doable, but it just seems tedious. So instead, let's try another approach. So our idea is going to be, what if we count the opposite of what we want and subtract that from the total number of passwords. And by opposite, we mean the complement. So if I'm trying to count the number, and I'm just going to write N for number, the number of passwords with at least one Z in them, this is going to be equal to the number of total passwords without any condition or restriction, the number of total passwords minus the opposite of what we want. So the opposite of passwords with at least one Z is passwords that have no Z's. So we're going to subtract the number of passwords with no Z in them. So visually, it's like, if I think about this in terms of a Venn diagram, there's this set that we're interested in. So I'm going to let this circle represent the passwords with at least one Z. So we're interested in counting this. And these live inside a universe, U. And U represents the set of all passwords. So the way we're going to figure out the number of elements in this set is we're essentially going to count the number of elements in U, which is all possible passwords, and subtract away the region outside of the circle. So the region outside of that circle is the passwords with no letter Z. We're going to subtract those away from the whole rectangle, and that'll leave us with the number of elements in that circle inside, which is what we care about here. All right, so let's count both of these things on the right-hand side. If I'm trying to count the number of total passwords, well, if I go back to the original problem, there are 26 letters and there are 10 digits. So collectively that means there are 26 plus 10, which equals 36 characters that can be used in any of the sort of places in my password. Okay, so we're gonna have 36 choices for every single spot in the password, sorry. And the password needs to have 10 total characters in it. Okay, so we'll have 36 choices for what goes in that first spot, and then 36 choices for what goes in the second spot. And we keep doing this because we're allowing repetition here. So overall, we're doing this 10 times because we're doing it for every single spot in our password. And our password needs to have 10 total characters. So this is 36 to the 10. All right, and now let's count the number of passwords that don't have a Z. Well, if they don't have a Z, that means we only have 35 choices for each digit. And in that case, we'll have 35 choices for the first digit times 35 choices for the second digit. And I keep multiplying this until the last digit, where I also have 35 choices. And again, this is 10 times because there's 10 characters in this password. So this gives us 35 to the 10. So overall, what we end up with is the number of passwords with at least one letter Z in them is equal to the number of total passwords, 36 to the 10, minus the number of passwords that don't have a Z at all, which is 35 to the 10. And that is our answer. So in terms of our goals, we finished the second goal, which is recognizing when and how to count something using complements. And the key takeaway is sometimes if we instead try to count the opposite of what we want, and that's easier to do than counting what we want, we can just subtract that away from the total, like we did in this previous example. So in the next video, we will do an example where we count the number of elements in a union of two sets when our sets are not disjoint.